Hello and welcome. Well, if you've gone through the first four set of exam prep sessions, congratulations. You've done a lot of hard work. This is the last one, so just hang in there for a few more minutes and then we'll have covered all the topics. In this video, my goal is to give you a high-level introduction to the AZ-700 certification exam. Just like with the other ones, this session is going to be relatively short, so you can listen to it maybe while you're commuting, riding your bike, whatever you might be doing. I hope this can be beneficial for you. We are going to be focused on the fifth set of exam objectives in the overall AZ-700 exam. And so what we're going to be dealing with is designing and implementing private access to Azure services. So let's wrap things up and get started with section 5. All right, made it to our last section, section 5, designing and implementing private access to Azure services. First two topics are Private Link and Azure Private Endpoint. So Azure Private Link enables you to access Azure Paas services. So for example, Azure Storage or SQL databases, and Azure hosted but customer-owned services over a private endpoint in your virtual network. So having a public endpoint means that the resource is assigned a public IP address. So even though both your virtual network and your Azure SQL database are located within the Azure cloud, the connection between them would be taking place over the internet. And the concern here is that you might have, as an example, an Azure SQL database that's exposed to the internet because of its public IP address. So that exposure creates a number of security risks. The same security risks are present when an Azure resource is accessed via a public IP address from a peered Azure virtual network, or if there's an on-premise network that connects to Azure using ExpressRoute, or if there's a customer Azure virtual network that connects to an Azure service offered by your own company. So Azure Private Link enables you to access these Azure Paas services over a private endpoint that exists inside your virtual network. So private endpoint, you have to understand what that is as well. So the private endpoint is the critical technology behind Private Link. Private endpoint is simply a network interface that enables a private and secure connection between your virtual network and an Azure service. So in other words, private endpoint is the network interface that replaces the resource's public-facing endpoint. So Private Link provides secure access to Azure services by replacing a resource's public endpoint with a private network interface. And private endpoint uses a private IP address from the virtual network to bring that service into the virtual network. So it's very important to understand this concept and make sure that you understand which types of resources would be reachable at a private endpoint or using Private Link based on their location in a network topology. You can use, for example, private endpoints for Azure app configuration in order to allow clients that exist on a virtual network to access data securely over a private link. The private endpoint uses an IP address from the virtual network for your app configuration store. Then network traffic between the clients on the virtual network and the application configuration store traverses the VNet using the private link on the Microsoft backbone network. And so that traffic is never exposed to the public internet. Azure Private Link allows access to a set of Azure resources over private endpoints, but it does require that those private endpoint records are registered in a corresponding private DNS zone. So because of that, it's important to correctly configure your DNS settings to allow clients to resolve the private endpoint IP address to the fully qualified domain name of the connection string, as an example for a database. Existing Microsoft Azure services may already have a DNS configuration, but keep in mind that that is for their public endpoint. That configuration has to be overwritten to connect using the private endpoint. So it's important to understand the concept that's in that red box. Make sure that you take a look at the link, the one that says Azure Services DNS Zone Configuration, and it will give you a listing of all the different private link resources that are leveraged so that resources can be resolved internally. So, for example, you might have a link that says private link dot app service windows.net. So you have to make sure that you're using that FQDN rather than the public FQDN to resolve those resources. Service endpoint policies allow you to filter virtual network traffic to specific Azure resources over service endpoints. So you might be asking yourself, how is a private endpoint different from a service endpoint? So we talked about private endpoints just a moment ago. How is that different from a service endpoint? A private endpoint, as we mentioned, grants network access to specific resources behind a given service, which allows you to be very granular in the way that you segment traffic. So traffic can reach the service resource from on-premises without using public endpoints. A service endpoint remains a publicly routable IP address. A private endpoint is a private IP in the address space of the customer's virtual network where the private endpoint is configured. So service endpoints are public, private endpoints use a private IP in your own network. If you want to enable a service endpoint, you have to do two things. First of all, you have to turn off public access to the service, and then you add the service endpoint to a virtual network. When you enable a service endpoint, you are restricting the flow of traffic and enabling specific Azure VMs to access the service directly from your private address space and preventing devices from accessing the service from a public network, like we see here in the diagram. A service tag, and I kind of alluded to this in one of the previous red boxes a couple sections ago. So a service tag represents a group of IP address prefixes for a given Azure resource. So Microsoft manages the address prefixes encompassed by a service tag and automatically updates the service tag as addresses change. And this minimizes the complexity of frequent updates to network security rules. So you could use service tags to define network access controls on network security groups or for Azure Firewall. You could use the service tags in place of specific IP addresses when you create security rules. So by specifying the service tag name, you could say something like database tier as a service tag name, in the source or destination field of a rule, you could allow or deny the traffic to that corresponding service without specifically defining the IP address for that database tier. With Azure VNets, you can place you can place many of your Azure resources in a non-internet routable network. So we use the concept of VNet integration in order to enable your applications to access resources in or through a VNet. However, VNet integration doesn't enable your apps to be accessed privately. In a lot of environments, you may have defined virtual networks and subnets with an allocated IP address range, and these virtual network resources are used to support multiple services and different applications. So as an example, if you're using Kubernetes, AKS clusters, Azure Kubernetes Services clusters, can use KubeNet, which is just basic networking for Kubernetes, or they could use Azure CNI, which is more advanced networking for connectivity. With KubeNet, only the nodes receive an IP address in the virtual network subnet. In other words, pods cannot communicate directly with each other. So if you need to communicate between pods, you would use user-defined routes and IP forwarding for connectivity between pods and across nodes. So if you have questions that deal with Azure Kubernetes, this is the way that communication can exist between clusters as well as between pods. And that's a wrap. It's a lot of stuff to study for this exam. If you want to find all the resource links as shown here on the slide, just search for either Thomas Maurer's AZ-700 study guide blog or the similar study guide by Charbel Nemnom, as I mentioned early on in the deck. I really do hope that this video study guide helps you with another method to focus your studying for the Azure networking exam. I hope you do well. I'd love to hear about your successes in passing the exam. Feel free to look me up on LinkedIn. I'm more than happy to connect with anyone if that's your desire. So, ciao for now, and let me know how you do.